Okay, so these circuits are a little bit different from the QTI circuit. In a charge transfer circuit, what you do is you allow the phototransistor to basically discharge a capacitor. So you charge up the capacitor and then you discharge through the phototransistor and or the photodetector, and then you look at the differences in time constants. This one works a little bit different. So what we do is the detector, it actually is only sensitive to IR pulses that are pulsing around 38 kilohertz. Okay, so what that means is that we have to manually turn on and off the IR LED at 38 kilohertz in order for the detector to see it. If you just turn this on, if you just said digital write pin 9 high and you started emitting IR, it does emit IR, and you can see it if you put like your cell phone on it. You can see the purple coming out of the LED, but the detector is not designed to see that. The detector is looking for IR that is toggling at 38 kilohertz. Now IR, now it's an interesting thing, because if you're saying hertz, you might say, well, IR is 300 gigahertz to 430 terahertz. When you look at like the wavelength of the actual electromagnetic radiation, it's like that's not what we're talking about. We're talking about yes, it is IR for sure, but we toggle it on and off, and that's just the way that the detector works. So we just got to do it. So we have to manually do that, and we'll come back to this later because it's very sensitive if you go right at 38 kilohertz, and it can see pretty far out. And sometimes you don't want that. Sometimes you want to like limit it to say I only want to look out maybe like 5 or 6 inches because it's seeing objects that are too far away, and I don't really care about them. Okay, so here's the process that we use. Okay, this is a waveform. This is an oscilloscope shot of this yellow. First of all, on the left, this is when nothing is out there. So we are going to turn on the LED and toggle it at a frequency of 38 kilohertz. This yellow right here is the voltage that you're observing that is observed across the LED. And so notice that we're going to manually turn it on and pulse it for a certain amount of time. And then what we want to do is read and see if the detector detected it. Okay, so if you don't see anything, if there's not an object out there, none of the IR bounces back, and the detector will read a high. Okay, if the radiation reflects, if the IR reflects, it will cause the detector to pull low, and we can read. The trick here is this. Number one, we need to turn on the pulse, so we're going to toggle it at 38 kilohertz, and then from the time you start, there's actually a little bit of delay for the energy to actually come back and be seen, so you have to give it a little bit of delay. So what we typically do is you start the pulse and you pulse it for, let's say, about a millisecond. But then what we do is, relative to that, we will wait a millisecond and we'll read over here. And what that does is it gives time for the IR energy to reflect and come back. It allows the detector time to discover it and pull this low. And then we're right over here, and we're right in the safe mode of when the detector is at a logic low. Then what we do is, after we read it, we go ahead and the tone can stop, or the pulsing at 38 kilohertz can stop, and then we wait a little bit longer before we proceed to our next portion of the program. Okay, so that's how it works. And let's see. You say, how do you do this code? Well, it's crazy simple, because we can actually use the tone function. So if you think about turning on this tone, all we do is you use tone pin 9 38 1000 hertz, 38 kilohertz, except for one little weird thing. As you get higher and higher in frequency with the pins of the Arduino, what happens is the duration becomes less accurate. So to get at something that's on for like a millisecond-ish, you actually have to put 8 right here. So notice that before, if we were doing something really low, like 500 hertz, we could have put 8, and that would have meant go for 8 milliseconds. Well, we're getting up to the point where we're getting to the maximum frequency that we can toggle one of these Arduino pins, so this number becomes more and more inaccurate. So empirically, the folks at Parallax have discovered that if you put an 8 here, that will give you about a millisecond on time. So all we do is we turn on the tone, and that's going to go ahead and do that. And then we do the delay for 1. And the reason we did that is we delayed from the moment that we turn the tone on until out to about right here. And then we simply just read from pin 10. And if it's a 0, that means something's in our way. And if it's a 1, that means nothing is there. Okay? All right, so let's give it a shot. Let's go ahead and code up code up this thing and see what we can do. So I'm going to start a new Arduino sketch, and first things first, always we want to go ahead and save this off. So I say save, and let's put this into our working directory. So we're going to come to, I'm working on the desktop, Arduino, and this is actually going to be chapter. If you're following along in the Parallax tutorial, this is chapter 7. This is the last chapter, but I'm going to go chapter 7, and then this is activity 1, and we'll call it IR Headlamp Test. Okay. All right. So we save that baby off, and let's go ahead and fire this baby up. So I'd also like my serial monitor to be somewhere. I'll bring that over in a second. Here we go. Okay, so we're going to go ahead and let's just do the IR. So serial dot begin 9600, and we'll just print the result to the screen, and then I'll also show you a serial or a oscilloscope shot of it. So let's do print line starting IR head lamp test, and that tells me my program's going. And I also like a little audible feedback here. I'd like to know that my program started up. So we'll go ahead and play a tone for a half a second. Life is good. And now watch this. Pin mode. We're using pin 9 and pin 10, so we have to set them up. Pin mode. Pin 9 is an output, and that's what the IR LED is on. Okay, so this is the IR LED. And then pin mode 10, and that's going to be input. And that's where the IR detector is. Okay, now we go down into here and we get in this loop, and all we're going to do is this. We're going to start off and say tone pin 9 38 kilohertz for a duration of 8, meaning that it'll be about 1 millisecond. So that means we just turned on IR, and I'm going to say pulse. So it's an IR, but I'm pulsing it at 38 kilohertz. Then I'm going to delay for 1 millisecond, and that's going to allow the energy to come back, and it'll be available to read on pin 10. And check this out. I'm just going to read from pin 10. So I set up a new data type of type byte, and I'm going to call it IR detect. So I got IR detect, and I simply do a digital read from pin 10. Okay, so now I got it, and let's go ahead and do a delay 100 just to kind of settle down a little bit before we print something. And what I'd like to do is now just do a print line and go IR detect. Okay, so let's see what happens. So the first thing I want to do is we'll save this baby and let me download. And of course you gotta put serial in front of print line, so I'll go ahead and save that. Okay, so it's downloading. I'm gonna grab my serial monitor over here and we'll pull it right there, and then let's pull up the guy on the camera here, and you can see, so here is my robot, or my BOE-Bot, and I have my sensor right here, and I've got it outfitted with an oscilloscope, so you can kind of see some stuff that's happening. And here we go. It started, played the tone, and I have starting IR headline, and look at it, it's printing a 1, so it's not seeing anything. So now here's what I'm going to do. If I put my hand in front of it, I start seeing a 0. Okay? And then if I take it away, I see a 1. And if I do this, I see a 0. And if I do this, I do a 1. Okay, awesome. Well, check this out. Since we're sitting here, why don't we go ahead and play like a high-pitch squeal for like, I don't know, 100, and then delay 100, and that way we can actually see the thing, we can see it and hear it. So let's go ahead and download that. Gives us just a little bit more feedback. course, that doesn't work at all, right? Because why would that work? we only want to play a tone if we see something. So what we're going to do is serial print, and then let's do this. If IR detect equals a 0, then play a tone. Otherwise, don't play a tone. Okay? So right now it's always playing a tone. So let's do that. Alright, so this is cool. So we're getting the code here for this guy. And I'm downloading it. Should stop blinking here. Here we go. Okay, so now watch this. I put my hand in front of it. Blinking like crazy. Blinking like crazy. Let's take a look at what the oscilloscope looks like. So here's an oscilloscope. So this is a live view of my robot here, and I have the oscilloscope over here, and what you see down here on the bottom is this is going to be the signal in real time of what I'm pulsing it. So I turn on the tone, 38 kilohertz. You can see it's just a square wave at 38K for about a millisecond, and then up here is what the detector sees. So you can see that there's coupling onto here, but it's not a logic low. But watch what happens when I get my hand in front of it. So I'm going to put my hand in front of it, and it goes nuts, right? And I take it away, put it there, take it away, put it there, and look at that. Isn't that awesome? So that's it. We now have the ability to sense what's in front of us. And what's kind of cool about it is that it was a different style of using IR. It's still IR, but it's using a different detector, and so a different circuit, and you just had to code it up a little bit different. Okay, so go ahead and give that a shot.